Hi guys, welcome to 7.2. Today we're going to be using the concept of ratios and proportions to talk about similar polygons. So there's just a couple things vocab-wise that we need to go through, and then we will get to our examples. So the first thing is, what does it mean to be similar? This whole year so far we've talked about things being congruent, and we know that congruent means they have the same size and same shape. But in similar shapes, they are basically polygons. Remember, polygons are just many-sided figures. Polygons that are similar have the same shape, but different size. All right, so similar means same shape, different size. So make sure you write that down. And there's a couple things that we need to know in order for something to be similar. The first is that all the corresponding angles must be congruent. Now, this doesn't mean corresponding angles like we talked about with parallel lines. Corresponding in this sense means the angles that match up, okay? So all the corresponding angles must be the same measurements. And then the second criteria is that all the corresponding side lengths must be proportional. And we'll talk about that more here in a minute. The little symbol that's in the parentheses right here, that is the symbol for similar, and I'll talk about that more a little bit later. Notice that congruent was this. Okay, and similar basically just takes the equal sign away because we know similar are not going to be congruent. They're not going to be equal to each other, but they're going to be close. All right, and then the ratio of corresponding sides, so this right here in this blank, that is called the scale factor. So you want to make sure you write that down. Scale factor is going to be really important as we start talking about how shapes are related. And also later when we talk about scale factors with drawings and you guys get to do your own, hopefully, that you're going to want to know what that means. And then it says if polygons are similar, then their perimeters are also proportional. So their perimeters are also proportional. So we'll kind of talk about that as well, knowing that as long as the shapes are related, then their perimeters would also have to be related. So these things on this page, make sure you write them down. They're very important. And then we'll go into a couple examples. So the first thing here, we've got two triangles. Now notice they are not the same size, clearly. All right, they've got different measurements. They even visually look different sizes. And what we're going to do is work with our scale factor and then talk about how we can find the ratio of the perimeters as well. So one thing that's important with scale factor is that scale factor, the order matters. So when you read a problem, you want to make sure that whatever shape or side or angle, anything that comes first is the one that goes on the top, and then the one that comes second is the one that goes in the denominator. All right, so it says what is the scale factor of ABC to DEF? So notice ABC came first, so ABC's side length is going to go on the top, and then DEF is going to go on the bottom. Now it says the triangles, but one thing that's nice about similar shapes is as long as they are similar, and in this case we're assuming they are, it doesn't matter which sides you pick as long as you pick corresponding sides. So what I'm going to do is I'm going to start with, I'll just work with AB. All right, so AB, its side is an 8, so that comes from triangle ABC. And then we know that the corresponding side that would go with it is DE. And if you weren't sure how I knew that, notice that AB is the first two letters and DE is the next two, the first two in the other triangle, so those have to go together. So the 12 is going to be on the bottom. And then, of course, I said this at the beginning, you always want to make sure that anytime you write a ratio, you reduce it. So obviously both of these can be reduced by 4, so we would get a scale factor of 2/3. And what this tells us is that the first triangle is 2/3 of the second one. So the first triangle obviously is going to be smaller than the second one because it is a fraction that's less than 1. Now notice if I said what's the scale factor of DEF to ABC, well now we're flipping it around. So all we would have to do is basically flip our fraction. But we could do this with any side and we should get the same numbers. So let's say I want to work with EF. Well, EF is here, so that's going to be the 15 on the top because that came first. And then that means it'll have to match up with BC. Well, BC is 10. So now if I reduce our fraction, both can be reduced by 5, we get 3 over 2. So notice it's the same fraction as the first one, just flipped around because I flipped my two triangles, the order of them. So what this means is that the triangle DEF is 1.5 times larger than ABC because it's a fraction bigger than 1. All right? And then we can use this to find the ratio of the perimeters, and then we can reduce those down as well. So since we're working with perimeter, and we have that DEF as the first triangle, I'm going to go ahead and find the perimeter of the first. So the perimeter of DEF, so triangle DEF, if I add up all of those sides, so 12 plus 15 plus 27, I end up getting 54. So 54 is going to be on the top. And then if I do the same thing for triangle ABC, and I add up all those sides, so 8 plus 10 plus 18, I end up getting, let's see, 36. And then 54 over 36, if we reduce that down, we should get 3/2. So what you should notice is that the ratio of the perimeter is going to be the exact same ratio or scale factor that we found with just the original triangles. So that's one key thing you want to make sure that you look at, is that if you can find the scale factor, then the ratio of the perimeters should be the exact same. All right, so that should be very helpful. Next, we're going to talk about similarity statements. Similarity statements, when we're talking about similar polygons or similar triangles, is very similar to our congruent statements. If you remember, when we talked about a congruent statement last semester, we would say triangle something is congruent to triangle something, or it'd be a polygon blank is congruent to polygon blank. Same thing, except instead of a congruent symbol, we put a similar symbol. So what's important though is that in order for it to be a valid statement, all the corresponding angles and sides have to match up. So this is where I told you guys originally, order matters. So if we look at the last example, so here we've got triangle ABC and triangle DEF. If I wanted to write a similarity statement for those, I would have to say that A, B, and C, so triangle ABC has to be similar to triangle, and then we'd have to go back in the same order. So triangle D, E, and then F. And what this tells us is that angle A would have to go with angle D, and angle B would match up with E, and angle C would match up with angle F, and then also that the corresponding sides would be the same. So AB would have to match up with DE, or BC would have to match up with EF, and so forth. Okay, so that helps you identify things that go together, just like we did in the congruent statements last semester. All right, so here's an example. This one doesn't have any numbers with it, but I'm wanting you to list all the congruent angles and then write a proportion that relates all the corresponding sides. So, and then in this statement particularly, you would have a similarity statement that would say this: triangle JKM is similar to triangle LTP. So if we were going to list all the congruent angles, angles are not usually written with proportions, so we would just say that angle J would have to be congruent to angle L, and angle K would have to be congruent to angle T, and then angle M would have to be congruent to angle P. And I just found that by matching up the letters, so J and L, and then K and T, and then M and P. So notice we just matched them up. Now, sides can be written as proportions. So what we're going to do is write the proportions that relate the sides. So if I look at my first side here, so JK, it's going to have to be a proportion that's written, or a ratio with LT, because those are corresponding. So JK, that's the first two letters, must go with LT. Well, if it's going to be a similar shape, that ratio of sides would have to be exactly the same as my other ratios of my other sides. So if I wrote a ratio of KM, okay, then KM would have to go with TP. Now, these are not congruent, okay, so I marked that wrong originally, so ignore the markings, but I'm just marking so you know which ones I'm working with. Km and TP are not congruent to each other. However, they are related in size, and that's what ratios and proportions tell you. So this ratio from JK and LT has to be the exact same ratio of KM to TP. And then same with the third side. All right, so JM, that's the bottom side, has to be related to LP. So one thing that's going to be very important, make a little side note to yourself, all right, is that all the ratios in a shape must be congruent in order for it to be similar. And that's what the rule that we were talking about earlier. So if I ask you in a problem to identify if the two shapes are similar, you'd have to make sure that all the angles are congruent, and then you'd have to find the ratio of every single side and make sure that when you reduce them down, you get the same fraction every single time. Because if I said that this was a length of 4 and then this was a length of 8, I took the 4 and I multiplied it by 2 to get the 8. But if I said that this was a 5 and this was a 15, I didn't multiply 5 times the same thing as I did the 4 to get the 15. Notice from 4 to 8 I multiplied by 2, but from 5 to 15 I multiplied by 3. So that means this side's 3 times bigger, whereas this side's only 2 times bigger, and it doesn't make it the same shape. So you have to be very careful. So in this case it would have to be 10 that would be there, because then I would take 4 times 2 to get 8, and 5 times 2 to get 10, and that would make these related. All right, so hopefully that makes sense as to why it's important that these fractions match up. All right, so now let's go through an example where we would use our ratios and our scale factors and proportions to solve. So here we've got just two figures. It doesn't really matter what kind of shapes they are. They kind of look like parallelograms. And it says that they're similar and they have a scale factor of 2 to 3. Now, notice that 2 is smaller than 3, and this left one is smaller than the right one. So we're going to go in the same order that they wrote this scale factor of. So 2 over 3 has to be the same as the ratio of these two side lengths. So that means the smaller one is on the top, and the bottom one is the larger one, which we don't know. So now we have set up a proportion, and this allows us to go ahead and solve. So we're going to cross multiply. So 2 times x is 2x, and then we multiply the means, so equals 3 times 42, and if we take 3 times 42 we get 126, so we get 2x equals 126, and then of course if we divide by 2 we get that, I'll erase that, we get that x is equal to 63. So that means that would be the side length of this particular shape. And of course, if you wanted to always double check, you could say 42 over 63, does that reduce down to 2/3? And you could always check that, and in this case it does, so you would know that x is the correct number in this case. Alright, so this is an example that doesn't give us a scale factor, however, it does give you the similarity statement. And that is just as good because now we can set up a proportion. So in this problem, it says that triangle ABC is similar to triangle DEF. So now all we have to do is use the similarity statement to match up what would be related. So notice we have AB as our first side, so I'm going to mark on this one. Well, AB is 25, and it matches up with DE because those are the first two letters. So DE is X. So we're going to write those as a ratio because AB and DE are related. And then we're going to do the same thing, but we're going to do it with our other sides that were given. So we have that BC is 20, so that's going to go here. And it's going to be, so BC is this one, related to EF, which is this one right here. So we can have 20 over 28. So notice that we wrote two ratios, and we set them equal because we want those side lengths to be related to each other. So now we can go ahead and cross multiply. So x times 20 is 20x. And then if we take the extremes and multiply them, so 25 times 28, we get 700. And then all we have to do is divide by 20. So divide both sides by 20. And we get that x is 35. So this tells us that DE is a length of 35. And we could always check in the end, make sure that when we reduce those fractions down, we get the same exact scale factors. All right, so that's all you have to do for these types of problems, is either use a scale factor and set up a proportion, or use the similarity statements and set up a proportion. And we've just got this one last one, and then you guys will be done for these notes today. This is the same type of problem. All right, they give you a similarity statement. The only difference in this one is that you have equations for your side lengths instead of just numbers like we did in the last example. So same process, just a few extra steps. So here it says triangle AGM is similar to triangle KXD. So we'll start with the left side. So AG is the first two letters, so that's 32. It's going to correspond with KX, which is right here. So that would be the x plus 3. Okay, and then the GM, which is the other side, so 36, is going to correspond with XD. Okay, so that would be x plus 6. So now we have a proportion set up. All we have to do is cross multiply. Now notice when you cross multiply this one, you get 32 times x plus 6, and then equals 36 times x plus 3. In this type of problem, I would suggest distributing and then continuing on from there. So if we distribute on the left side, okay, we would have 32 times x, that's 32x, and then 32 times 6 is going to get us 192. And then same on the other side, 36 times x is 36x. And then 36 times 3 is going to get us 108. And now this is a problem that you guys could solve. So we could say 192 minus 108. That's going to get us 84 on the left. And now if I subtract 32, oops, that should be 36x. If I subtract 32x over to the other side, I get 84 equals 4x. And now I can take 84 divided by 4, and we get that x is equal to 21. Now notice this problem, all they wanted was x to be equal, or they wanted you to find the value of x. However, I could ask you to find what dx or xk's lengths are, and then ask you to find the scale factor. So the one thing that's unique about these kind of problems, it's not always going to just be solving for x. In some cases, I just want x. In some cases, I want a side length. And in other cases, I may want a side length and I may want the scale factor. Remember, the scale factor is just the ratio, the ratio of the sides. So just pay attention to what they're asking for. Just remember similarity statements, the order matters, and same with scale factors. The order of the shape that it comes first, that will go on the top. The second shape that comes second will go on the bottom. All right, so just make sure you got those, and if you have any questions, let me know. But you guys are good to go. Thanks for listening.